started. Now, any question on what we have covered so far? Any question? No question? Okay. Now, so what? So help me. Help me with what did we cover yesterday? What all did we cover yesterday?
So yesterday we covered about the probability and how to calculate the probability. We learned about the normal distribution bell curve and how the mean, median, and mode are calculated, and we also learned how to make any of the graph or any of the distribution equivalent to normal distribution, and then find out the value for any of the z point in that graph.
Okay.
Yeah.
Cool. So we started with probability yesterday. Then we talked about what is a distribution and what is probability distribution. We talked about central tendency and dispersion, right? Now, having said that, what is coefficient of variation?
Coefficient of variation is a unitless. I exactly don't remember the formula, but we normally use it when we need to compare the unrelated.
Yeah. See. So again, you will see a lot of formulas here, right? I frankly do not remember the formulas, right? So what I try to remember is the logic. And if you remember the logic, you can get the formula from there. So for example, coefficient of variation, what are we trying to do here? We are trying to compare standard deviation across cases. Now, if you compare standard deviation across cases, you need to normalize it. Easiest way to normalize is divide by mean. So then what is coefficient of variation? Standard deviation divided by mean. Right? Okay. Then we talked about probability distribution. Probability distribution, within that we will be talking primarily about one probability distribution because this is the one which is mostly used. It's known as normal distribution or a bell curve or a Gaussian, and also it's known as Z distribution, right? So these are the names of the same distribution. Now we discussed some of the features of normal distribution, right? But before we go into the feature, what I missed yesterday was showing you what is the equation of a normal distribution, right? Equation of the normal distribution is this, right? Now to simplify this, if I can simplify this, what it means is a normal distribution is a bell-shaped curve, right? So I want an equation which can build this bell shape. Right? This is what I want, right? Okay. Now, what is this equation? This equation is known as probability density function. Its sole purpose is, given a value of x, it tells you what is the probability that the variable will take that value. So basically, given a value of x, it tells you the y-axis. Make sense? So if I can get an equation of this line, if I put in x there, I'll get y, no? Okay. Now, so how does the equation look like? The equation is f of x, it's a function of x, right? So f of x is equal to 1 by root 2 pi sigma square. So basically 1 by square root of 2 into pi into sigma to the power 2 into e to the power minus of x minus mean to the power 2 divided by 2 into sigma to the power 2, right? I'll come to it. As you can see, I don't remember this, right? So you don't need to remember this. But what the reason I am showing you this function is A, you should be aware what this looks like, right? And B, you should know that a normal distribution is dependent on two things apart from X. It is dependent upon two things. What are the two things? Mean and sigma. Sigma is standard deviation, right? Instead of sigma, I can write standard deviation. Right? So you do not need to remember this. This is only there to remind you that if somebody tells you that a variable follows normal distribution, your next question should be what is the mean, what is the standard deviation? Because until and unless you know that, you do not know what this distribution is actually, right? You know it's a bell shape, but you do not know how exactly it looks like, right? Because you see, this is a normal distribution, right? And this is also another normal distribution, but are they same? They're not same, right? Because their mean is different, right? Similarly, I can have another normal distribution which looks like this. Are they same? No, right? Because the standard deviation is different. The point is, if you change mean and standard deviation, the normal distribution will look different, right? So if anybody talks about some variable following normal distribution, you should ask that person, what is the mean, what is the standard deviation? Make sense? These are known as parameters of a distribution. Parameters mean the variables which you need to give in order to form the distribution. Yeah. So every distribution will have different parameters, and we'll talk about some more distributions. For normal distribution, the parameters are mean and standard deviation, right? But if somebody talks about standard normal, you need to ask what is the mean and standard deviation, because it's known. Standard normal means mean is 1, standard deviation is, sorry, mean is 0, standard deviation is 1, right? Okay. Now, we talked about certain properties of normal distribution. What are those properties? First property is very simple. It's bell shaped, right? Okay. Yes. Second property is it is symmetric about mean, mode, median, because they are same, right?
Mean equal to median equal to mode.
Yes. Third is mean is equal to median is equal to mode. Next.
On the either side, it goes till infinity.
Yeah, it's continuous from minus infinity to plus infinity, right? Yes. Next. Yes. So as a consequence of symmetric, right? If we move X amount, or let's say D amount to right from mean, the probability to the right is exactly equal to probability to the left if we move D amount to the left from mean. Make sense? So the point is, since it is symmetrical, if we move D amount to the right, the probability to the right of that point will be exactly equal to the probability to the left of a point if we have the point moving in D amount in the left direction. Make sense? Yeah. It's symmetric, right? If I move D amount and calculate area to the right, and I move D amount to the left and calculate area to the left, this will be equal. Areas. Area is nothing but probability here. When I talk about area in terms of probability distribution, it means probability. Yeah. So, I mean, see, if you think about this, right? So what is a probability distribution? Probability distribution is a line which captures the probability under it, right? So what is the total area under this curve? 1. So if I talk about area to the left of this line, it basically means probability that this variable will take a value less than equal to this. If I talk about area to the right of this line, it is equal to probability that the variable takes a value greater than equal to this. Make sense? Okay. Next. Again, as a consequence of symmetricity, what happens is probability that is captured between mean plus sigma, sigma means standard deviation, and mean minus sigma is equal to 66 point something percent, right? Okay, next. If we move by 2 sigma on either side, the probability becomes 97%. Third, if we move by 3 sigma, the probability becomes 99.7%. Make sense?
So how do we get this?
You can get this easily if you can integrate this function. We have to integrate this function from mean minus sigma to mean plus sigma. You'll get exactly 0.66.
Okay.
Okay.
In the graph, what will sigma be? We understand is the vertical in the center, but
sigma
what will be the
is
sigma?
the standard deviation, right? So if you can draw a line here, standard deviation is the spread of this line, right? You cannot show this sigma in the graph, but what you can show is between plus minus 2 sigma, there is 97% of the area. Sigma is something which will not be able to show directly in the graph.
Right. Because it's from infinity to infinity.
No, it's not because of that. Mean is a point, right? Point you can show in a graph. How do you show a spread? Spread, it is not possible to show in a graph, right? So you can show that spread as a consequence. You can say that between mean plus minus the spread, I have 66% of the probability.
Okay.
What is sigma? Sigma is spread, right? How do you show spread in the distribution? There is no way to show the spread. What you can
doing
tell
yesterday,
is,
like you were doing yesterday, minus x to plus x.
Yeah, exactly. So what did I say yesterday? That between mean plus minus standard deviation, bulk of the observations will lie. Right? Which is 66%. Do you understand?
Yeah.
Okay. Now, any other property? Yeah. So we discussed a couple of points, right? We discussed how do you go from a normal mean comma standard deviation to a n 0,1, right? You see when somebody was telling me or helping me remind this, she told me that you can use this to go from any distribution to standard normal. That is not correct. You can only go from a normal distribution to a standard normal, right? You cannot go from any distribution to normal.
Okay.
The way you do this is by subtracting the mean from each value and dividing it by standard deviation, right? This will follow normal 0,1. right? Okay. Now, so these are the properties of the normal distribution. The next concept that we are going to study is a concept known as sample and population. Now, what is a sample? Sample is a small portion of the some larger population, right? Now, in statistics or in analytics, prior to the advent of machine learning and big data, people only could work on samples. And even now, in certain cases, they could only work on samples, right? Why? Because it is either too time consuming to get the population, or B, it is not even possible to get the population, right? Say for example, if I ask you, give me a estimated value, or tell me what is the average age of Indian male living in this country. How will you calculate that? Will you go to every Indian male and ask their age? It will take forever, right? It takes 10 years for the census to happen. It will take 10 years to get this done, right? But no business will wait for 10 years, right? In fact, nothing will wait for 10 years. So what you will need to do is you will probably collect a sample and then somehow get an estimate of the population average using the sample, isn't it? So my question is, what is the average age of Indian male? Now, when I say average age, I mean the average age of the population, right? Now, how do you go about calculating this average age? You will use a sample. Sample means a small portion of the population, and somehow try to guess the population average. That's what you can do, right? You will get a sample and use some method to get a good guess about the population average. All of you agree? No. When I say population average, I mean population of Indian male. Yeah. So population is a term which is not same as the Indian population. In statistics, whenever we say population, we mean a particular part of it. So here, when I am talking about Indian male, my population becomes all Indian male, not the whole Indian population, right? So here, no, here population in English and population in statistics is different. In statistics, whenever I say population, I mean the population under the question you are trying to find out. Yes. So if I talk about, give me the, what is the average CO2 emission by a car in India, right? Now, here when I talk about population, I'm talking about all the cars in India, right? So in analysis, whenever you talk about population, it is the population that you are interested in, not the population of the whole country or the world, right? Okay. So if I am trying to find out, now forget about this question. So forget about this, let's only stick to one. If I am trying to find out the average age of Indian male, my population is all Indian male, right? Now, how do I go about finding the average age? I will probably collect or randomly choose some people, use that as my base to somehow guess what could be the average age. That is the only process, right? Or do you think there is something else? Nothing, right? This is the only way? Okay. Now, this guess is an English term, right? The scientific term of this guess is known as estimate, right? Estimate is a scientific term which is used instead of guess. Okay. Now, you can have n number of such questions which talk about inferences on a large population. For example, CO2 emission. I can ask you how many trees are there in India, how many cars do people drive, all sort of questions, right? In all of these cases, your population will be huge, and the only way to answer those questions is by collecting a small sample. Make sense? To answer all of those questions, the techniques that we are going to use is known as estimation techniques. Right? The techniques that we are going to use is known as estimation techniques. Now, estimation techniques are of two types. First is known as point estimation. Second is known as interval estimation. Now, what is point and what is interval? Let me explain this with an example. Let's say you have given an exam, and after you have come out of the exam, somebody is asking you how much are you going to score in this exam. There are two ways to answer this question. Either you say that I will score exact 70, or you say I will score anywhere between 60 to 70, right? The first method is known as point estimation. The second method is known as interval estimation, right? So point estimation is trying to give you a exact guessed value, right? It is, remember, it is a guessed value, right? It might be true, might not be true. See, whenever I ask you about average age of Indian male, whatever you tell me is your best guess, right? It might be true, it might not be true. Think about exit polls, right? Exit polls are often true, often they are not true, because they are based on a sample. Make sense? Okay. Interval estimation.
It should not be exact.
Yeah.
Then.
Yeah,
It
exact means a pointed value.
Okay.
Interval estimation means it will not give you an exact pointed value. It will give you a interval with a degree of surety, right? Now, whenever say somebody is asking you how much you are going to score, you typically say that I will score between 60 and I am 90% sure that I will score between 60 and 70. Right? You usually give a confidence along with the interval, right? Because somebody might say that I will score between 0 to 100. That is also interval estimation, right? And somebody might say I will score between 60 to 70. That is also interval estimation, right? The only difference is in confidence. You are 100% sure that you will score between 0 and 100, because 100 is maximum, 0 is minimum. There is no way you can score anywhere beyond that. But if you narrow down the interval range, your confidence will keep on reducing. Right? Makes sense? Now, hold on to this thought. I will come to this. Can you switch on the AC? It is switched on? Yeah. Okay. Now, let's start with point estimation because it's simpler, right? Point estimation. Point estimation. Whenever we talk about point estimation, we are typically interested in two things about population. In all point estimation cases, we are typically interested in two things, two major features of any distribution. What are two major features of any distribution? Central tendency and dispersion. So whenever we are talking about point estimation, we will either be estimating the central tendency or will be estimating the dispersion, right? Now, whenever I talk about central tendency, what is the most important measure? Mean.
Mean.
So whenever we talk about point estimation of central tendency, we will be talking about estimating the mean or the population average. Make sense? Now, there is two concepts here: population average, sample average. All of you understand the difference? Population average is a hypothetical number that you may or may not know, which is calculated on the full population. Sample average is a number which is calculated on the sample that you have. There is a difference between them. Make sense? So in our case, when I calculate the average age of Indian male, the population average will be probably the data from census. Census actually goes door to collect data, right? So they will have exact data on all Indian male. I can use the census data to get the population average. When I talk about sample average, my sample average will be only based on 10, 20, 30 points that I have calculated. Make sense? Okay. Now, so I talked about the fact that whenever we are trying to estimate central tendency, we will try to estimate mean. Now, if somebody talks about how can you estimate mean of the population using your sample, you can come up with different ideas, right? One can say that what I will do is, out of the sample that I've collected, I will choose a random value and use that as an estimate. One can say that, right? It is his guess, right? So the option can be a random value. Second option can be you can take the minimum of the sample, right? It will be a pessimistic estimate. Similarly, you can take the maximum value that you have found in the sample, right? Or you can take the sample average, right? Similarly, you can have a lot of choice depending upon what you think is the best estimate. Yeah.
So, but mean is always an average. So, how can we take random value also?
No, I mean, say for example, let's say I ask you that what do you think is the average age of Indian male? Somebody might say that I'll randomly pick one person and whatever his age is, I'll say that is my estimate. Nobody is stopping you, right? It's your opinion against mine, right? Then somebody might say I will take 5 people and take their minimum age as the estimate. Somebody might say I will take 5 people, take their maximum age as the example, as my estimate, right? Similarly, somebody might also say that I'll take 5 people, calculate their sample average. Sample average means average age of those 5 people and use that as my estimate, right? Different people might have different opinion, but in statistics, it can be mathematically shown the most accurate estimate of population mean is sample average, right? This is known as most powerful unbiased estimator of the sample of the population mean, right? So whenever somebody asks you about to estimate the population mean, the best possible answer that you can give is sample mean, right? It can be mathematically shown. If you're interested, study about unbiased estimator and power of an estimator, right? So that in those cases, it can be mathematically shown that sample average, if you have a large enough sample, will converge towards population average. Make sense? Okay. Similarly, if you are trying to estimate dispersion, which is the most common measure? Standard deviation. Most common measure of dispersion is standard deviation. Now, the most accurate way of estimating the population standard deviation based on a sample is sample standard deviation. Now, the sample standard deviation calculation is a little bit different from the standard deviation calculation we learned yesterday, right? This sample average is same as normal average. But when I say sample standard deviation, it is a little bit different from the standard deviation calculation we have learned yesterday. Now, having said that, what is the calculation did we learn yesterday? What is normal standard deviation?
It's like having
What is the
into
formula for
subtract
normal standard deviation?
Square root of mean
subtract minus
value.
mean
So it
upon
is square root of 1 by n, n being number of observations, divided into summation of, all of you understand this summation sign? Okay, so there are a couple of mathematical symbols that I've used, right? One is sigma. Okay, this sigma. This sigma stands for summation. Yeah.
This is sum of all observation divided by a number of observation and then square root of that.
I'm explaining, right? Sigma stands for summation. X bar stands for mean. Okay, what this means is I am subtracting mean from every observation, squaring it up and summing it up, and then multiplying 1 by n. What do I get? Average of this, right? This is the formula for standard deviation that we have learned yesterday. When I say sample standard deviation, the only change here is instead of n, you multiply it by n minus 1. 1 by n minus 1. This then becomes sample standard deviation. Now, this sample standard deviation is the best possible estimator for population standard deviation. Population standard deviation follows the same formula that we learned yesterday. Makes sense? If somebody asks you what is the population standard deviation of age for Indian male, your answer should be sample standard deviation on a sample that you have collected.
So why do we divide by n minus 1?
Yes, the reason we divide by n minus 1, because mathematically it has been seen that the 1 by n minus 1 converges towards the population standard deviation. If you use 1 by n, it will not exactly be equal to population standard deviation. I mean, it will not converge to that. 1 by n minus 1 converges to population standard deviation.
Sigma is from I is equal to 1 to n, but the division is by n minus 1.
Yes.
Okay.
Because again, this all again can be explained in higher order mathematics. So in higher mathematics, it can be shown that as you increase the sample size, this quantity converges towards population standard deviation. If we use 1 by n, it will not converge towards population standard deviation. Yeah, you get this from a derivation. Exactly. Yeah. So xi, x bar, these are all on the sample. Yeah. Everything is on the sample. This is known as sample standard deviation. This converges towards population standard deviation. What is population standard deviation? 1 by capital N. Population number is usually represented in capital. 1 by capital N divide into summation of I is equal to 1 to capital N into xi minus capital X bar. Now, what is capital X bar? Population mean, right? To the power 2. This is what it means, right? Sorry, not xi bar. How do I erase this? Eraser. Yes. So what I am saying is this quantity that we looked at, right? 1 by n minus 1 summation 1 to n x I minus x bar to the power 2. This converges towards square root of 1 by capital N summation over 1 to capital N xi minus capital X bar to the power 2. Right side is for the whole population. I mean, imagine this case, right? What I'm saying is here, the left hand side is only the sample that you have collected. Imagine this, you have data on all Indian male with you, right? Then you could have calculated this, right? So mathematically, it can be shown that the left hand side converges towards the right hand side as you increase the sample size. What's this? 1 by n. We took average, na? Average means multiplying by 1 by n.
And then you are also replacing small n with capital N.
Where?
Above summation.
Yeah, here. Yeah. So capital N means for the whole population. Yeah. So here I am summing up for the whole population. Small n means your sample size, capital N means population size. No, I'm not saying that. Why will that be? Right? Small n is your sample size. Imagine what will be the Indian male population, around 60 crore. So capital N is around 60 crore. Small n is around 10. Okay. I'm saying you should, the best estimate of the right hand side is the left hand side. Right? That's why I have not written equal to. This is not equal to, this converges. Right? So tilde and followed by this means it converges. Yeah. Makes sense? Okay. So if I ask you what is the best estimate of population standard deviation, it will be sample standard deviation. Remember, sample standard deviation, whenever you talk about this, the calculation will always have 1 by n minus 1 in the denominator, right? It will not be 1 by n. Make sense? Okay. Now, yes, you have a question? That's what I'm saying, right? So if you just take 1 by n, it will not mathematically converge to the population standard deviation. It will only converge if you take 1 by n minus 1. So you will reduce the error. Right?
Sir, I have one question.
Yes.
In the earlier equation that you had written, there should be some relation between the small n as well as the capital N as well. When you take but when you take a sample size of 10 and you take a sample size of, let's say, 10 crores, you know, it should, you know, the standard deviation should make a difference, practically speaking, no?
Yes. But my answer to your question is, if all of this that I have written is for a given sample. So if I give you a sample and tell you what is your best estimate of the population standard deviation, your answer will be sample standard deviation. Okay. If the sample changes, obviously the sample standard deviation calculation will also change. If you increase the data, you will obviously get a better estimate. But given a data, this is the best possible estimate.
But the accuracy level and the probability of getting the right
yeah, the accuracy will increase as you increase the sample size, But given a sample, this is the method that you should use.
Okay.
Okay. Now, the next concept is interval estimation. Now, interval estimation, like I said, talks about giving an interval with certain degree of surety. Make sense? Okay. Now, in order to understand interval estimation, we'll have to understand a theory which is known as CLT, or central limit theorem. Now, what is central limit theorem? Central limit theorem states that if it basically states that what is divided by count and we did not divide it by average, we calculated average. That is coefficient of variation. Sum of, we did not take the sum of that, we took the average of that. If you go here ना, यहाँ पे calculate किया ना. So if you look here, what I have done is I have taken here the average, right? Then I took a square root. I did not divide by anything. No? Average means what? Multiplying the sum by 1 by n. No? Okay, now central limit theorem. What is central limit theorem? Central limit theorem, let's first state the theorem and then we'll come to what is the implication. Central limit theorem states that sample average follows a normal distribution with a mean equal to the population mean and a standard deviation equal to population standard deviation divided by square root of the sample size. Okay, this is the central limit theorem. Central limit theorem states that sample average follows a normal distribution where the mean of the normal distribution is same as the population mean and the standard deviation is same as population standard deviation divided by square root of the sample size. Now let's understand this with an example. Now let's take the same example where we were trying to estimate the average age of Indian male. Right? Now, we talked about the fact that the only way to do this is by taking a sample. Now, what I'm saying is, instead of taking one sample, what if you take multiple samples? Right? What if every day you find 10 people, 10 random people and note down their age? You do this for 10 days. How many samples will you have? Okay. So let's say every day you randomly select 20 people and repeat this for 10 days. So how many samples you have? 10 samples. Each sample having 20 observation. Make sense? Okay. Then what you can do is calculate average of this 10 samples. You can calculate the average. Yeah. So how many averages you have? 10 averages, right? Now, if you plot a probability distribution of this average, Probability distribution of the average means in the x-axis will be average values, in the y-axis will be probability to get those values. Make sense? If you plot a probability distribution of this average value, it will look like a bell curve. Yes. No. You got 10 averages. Now go back to the example. So for example, let's say for these 10 days, these are the 10 average numbers. What I'm saying is get their probability distribution. Similar to what we did yesterday, you can get the probability distribution. If you get the probability distribution, it will look like a bell curve. You understand probability distribution, right? In the x-axis, you will be values that you have got. In the y-axis will be probability that you have got this value.
Frequency distribution.
Sorry?
Same as frequency distribution.
Sorry, I didn't get you.
I said similar to frequency distribution.
Yeah, the shape will be similar to frequency distribution, but it's just that you divide frequencies by the total observation. So you get probability. No. Now observation, there are no observations, right? Now we're dealing with samples. There are 10 sample points for which you have plotted the distribution. So you have 10 different values for which you have plotted the distribution. Forget about the original observations. So I'm talking about distribution of these averages. I'm not talking about distribution of the values. Initially, you had 200 values from which you calculated 10 averages. Now I am only talking about these 10 averages. Forget about those 200 values. If you take a probability distribution of these 10 averages, you will get a bell-shaped curve.
What will we get in y-axis?
They will be similar, right? That is one of the feature of normal distribution, that most of the observations are very similar to one another, right? That's why the bell shape comes in. So what will happen? Why do we get a bell-shaped curve? Let me explain very intuitively. See, we talked about the fact that if you have a large enough data point, every distribution is normal, right? So let's understand, let's assume that the underlying distribution of Indian male age is normal, which makes sense. Most of us will be of some averages. There will be very few old people because they would have died, and there will be very few young people because they are still in the growing up process, right? So let's say the distribution of the age for Indian male is normal. Now I am talking about selecting 20 random people every day for 10 days, right? So if you select 20 random people and you are selecting 10 sample, what will happen? Most of your samples will come from this region because this is most frequent. 1 or 2 days you might get a sample which lies somewhere in the extreme. Make sense? Maybe 1 or 2 days somewhere in this extreme, right? So when you plot their averages, imagine what is the shape you are getting. When I say, for example, if I would have got these 10 observations from this region, what will be their average? Somewhere around here. If I would have got 10 most of the observations from here, what will be their average? Somewhere around here. And for this sample, the average will be somewhere around here. Exactly. So it comes out to be bell curve. That's my whole point. So in central limit theorem, it states that if you plot the average, you get a bell curve. Because the underlying population is also a bell curve. So your sample also comes in terms of bell curves. Each sample from each sample calculate average, get a frequency distribution of the average. That will also be bell shaped. Make sense?
Sir, can you please repeat your last line, frequency distribution one?
Yeah. So if you calculate sample averages and get frequency distribution or probability distribution of those sample averages, the probability distribution will be a bell-shaped curve.
Okay. Okay.
Okay, now bell-shaped curve, we just now understood if it is a bell-shaped curve, there will be two parameters that will be there. What are the two parameters? Mean and standard deviation. All of it clear? Now, we understand that it will be a bell-shaped curve. Now let's understand what will be the mean and the standard deviation of the bell-shaped curve. It can be shown mathematically that the mean will be exactly equal to the population mean. Because you see, most of your samples are coming in and around the population mean, because that's the most common fact, that's the most common value, right? Because mean is equal to mode in a bell curve. So most of your values come in and around the population average, right? So the distribution that you get is also centered around the population average. So mean become exactly equal to the population mean. Standard deviation is equal to population standard deviation divided by square root of the sample size. In our case, what was the sample size? 20. Make sense?
Sir, here for
Yes.
population mean, I got the point that whatever the mean of the bell curve we'll find out for the sample will apply to the population mean. But when we are saying standard deviation, why are we dividing it by the square root of n?
Because it is coming, I mean, again, it comes through a lot of mathematics, and it can be shown that this is what the value is the resultant value actually.
Okay, so the standard deviation for the sample will be applicable to the population sample only if it is divided by square root of n.
No, there is no sample standard deviation here. What
Okay.
I'm only saying is, if I could go out today and calculate, get 10 people's ages, calculate their average, I will know this average that I'm seeing is coming from a distribution which has a mean exactly equal to the population average age, and a standard deviation equal to the population standard deviation divided by square root of 10, because I took 10 people.
Okay, got it.
Okay, so none of these, so there is no sample mean and no sample standard deviation. Both of these are population. Makes sense? This is the theory, right?
Yes.
So given a sample, so if you have to plot the bell curve, you will take 10 samples. But yeah, every day 10 people, which is one sample. Or every day 20 people, one sample. Repeat this for 10 days. If you plot it, you will get a bell curve.
So on x-axis there is a probability, and on y-axis what is that there? So
How can
on
I?
x-axis there is probability, and y-axis.
One second. I'm coming to one line. Yeah. You will get a bell curve. Yes. A bell curve is a normal distribution. A bell curve is normal distribution, right? So it is normal distribution. It does not apply. Okay. Now, what was the question from online?
So what is there on y-axis?
Yes. So in a normal probability distribution, what is in x-axis?
That will be
So here in probability distribution, probabilities.
samples of
In
averages.
probability distribution, again, you have to get these concepts clear. In a probability distribution, there is only one thing to remember. In the x-axis will be values of the variable. In the y-axis will be probabilities. So in our case,
Okay.
the variable is average age. So in the x-axis, we have average age. In the y-axis, we have the corresponding probabilities.
Okay.
Okay.
Fine.
Yes. No, there is no assumption. There is no assumption. I just showed you using a normal distribution because it is easier to show you. But this applies, central limit theorem applies universally to all distributions. No, no. Irrespective of whatever the population distribution, central limit theorem will always apply. Okay. Now, Again, I would reiterate the central limit theorem because it is a bit convoluted. So here we are talking about not the distribution of age, but rather we are talking about distribution of the sample average, right? Not the sample value, sample average. If you would have had multiple hundreds of samples, if you would have plotted their distributions, you would have got a bell curve, right? Sorry? Simple. So for example, I will take simple values so it is easier, right? So let's say I take 10 samples. At 10 samples, each sample is composed of 20 observations, right? 10 samples. So what I do is for each sample, I calculate average. Make sense? Okay. So let's say for the first sample, the average is 2. For the second sample, the average is 3. I am simplifying it. It will not be in exact integers. It will be in decimal. Again, for the third sample, it is 2. For the fourth sample, it is 3. For the fifth sample, 4. For the sixth, 5. Then again, 2, 1, 2, 2. I've got the sample averages. Now, can I make a distribution out of this? Yesterday, we did this, right? I can create a distribution about this. That will be the distribution of the sample average. Yesterday, we did this, right? No, we will take what are all the distinct values. What are the distinct values? Let's start with 0. 1, 2, 3, 4, and 5. These are all distinct values. Then we will take their frequency. How many times 0? 0. How many times 1? 1. How many times 2? 1, 2, 3, 4, 5. How many times 3? 2. How many times 4? 1. How many times 5? 1. Right? If I plot this, I'll get the frequency distribution. If I divide each frequency by the total sample size, I'll get the probability. I plot this, I get the distribution. Right? This is the distribution of the sample averages. Make sense? If you actually could get a sample and plot it, you will see it forms a nice bell curve. If you're interested, go on YouTube. They have very nice videos where they sample for different distributions, and you will see as the sample size increases, or as the number of samples increases, it forms a nice bell curve. They have a lot of animation. Just go and search on central limit theorem animation. You will see. Hmm. Hmm. These are averages, right? I told you 2 is the average of the first sample, 3 is the average of the second sample, and so on. These are actually averages. This is sample number and this is sample average. I took integral values because it's easier for me. Yes, we will, no, not the standard deviation, but we will use this, right? So you understand this theory? Now, going back to one of the properties of normal distribution. So can we say that since sample average follows normal distribution with a population mean between this and this, sorry, for normal distribution with a mean equal to population mean and standard deviation equal to this, can we say this, that sample average will lie between population mean plus, okay, before we do that, there is a shorter name that is given to this quantity. There is a name. It's in order to avoid writing this whole thing, people have given this a name which is known as standard error. Standard error is nothing but population standard deviation divided by square root of n. That is the name of this, right? Okay, so since I know this first line, now coming back to this, since I know this first line, can I write this? AC is standard error. Can I write this? Yeah, minus. Can I write this? Yeah?
Yes.
Okay. Sorry? With 66% probability, right? I can write this? All of you agree with this? Okay. If I can write this, then what I will do is I will bring the population mean in, this is an inequality, right? I'll bring the population mean on this side of the inequality. Yeah, let me write this and then let me know if you don't understand. All of you understand this? And I mean, this statement remains valid, right? So this will be true. Okay. All of you agree with this? Okay. Now, let me know if you agree with the next statement or not. I just multiplied the whole expression by -1. All of you understand this? Okay. And this statement still remains valid, right? Okay. You agree with this? Okay. Now do you see, do we have a interval estimate for population mean? We have an interval estimate for population mean, right? Given the standard error, obviously. If you know the standard error, you can get an interval estimate of population mean using central limit theorem.
So can you please repeat?
Yes. Now, tell me which line did you not understand? Are you comfortable with the first line?
First line, can you
This?
explain the first line? Yes.
Yeah, so I am saying that sample average follows a normal distribution with a mean equal to population mean and a standard deviation equal to standard error. Now, if that is true, can I say that this statement is true? Because remember, yesterday we talked about between mean plus minus one standard deviation, there is 66% probability. I have just written that same line in a different way. Make sense?
What SE stand for you, sir?
SE stands for here standard error.
Okay, cool. Thanks.
Okay, so this is the way by which you can estimate, give an interval estimate of the population mean. Interval estimate of central tendency does not exist. So whenever we talk about interval estimate, we will only be talking about interval estimate of the population mean, and this is how you can give the interval estimate.
So can you please explain the last line? This is the last line.
Yes, so in the last line, what I did was I moved the sample average to both the sides. I moved the sample average to the other side, right? So it becomes positive sample average and it moves on to both the sides.
And what this signifies, the last line?
Yeah, the last line signifies that population mean lies between sample average plus minus one standard deviation with a 66% probability. Now, what does that mean? Now, let's say you know the standard error of the population. Let's say that is 10, right? Let's say the standard error is known and it is 10. Now, if I ask you, give me a 66% confidence interval for the population mean, what will you do? You will directly go and take a sample, calculate sample average, and then you can directly give this interval estimate. You will get a range of population mean with a degree of confidence. This is degree of confidence or certainty, right? 66% certain, right? Okay. Now, there is another interpretation of this. What is this interpretation? Let me rewrite the last line. The last line is basically sample average minus population standard deviation divided by square root of n, right? Greater than equal to population mean less than equal to sample average plus this, right? This is the last line. Now, if I increase the value of n, will my interval become narrower or wider? If I increase the n, any sample size, right? Any sample size, right? If I increase n, will the intervals become narrower or wider? Narrow, right? The interval will become narrower, right? If we increase n. Now, what does that signify? That signifies that the more data you have, the more accurately can you estimate. Because you see your interval becomes smaller and smaller, right? Yeah, standard error becomes small. So if you increase the sample size, which means the more data you have, the more accurately can you estimate a particular parameter. Yeah. Yes. Narrower will be the confidence interval. Narrower will be the interval. So, for example, if you let's take an example of election, right? So if you, let's say if somebody asks you how many seats is BJP going to get in the next election, let's say you have only 10 observations to decide. Your interval will be maybe 200 to 300, right? Now, if I am analyzing and I have 10,000 observations, my interval will be narrower, right? It is coming from this theory. As we increase the sample size, the interval becomes narrower. Now, again, another question. If I want to increase this confidence level, will my interval become narrower or wider? Wider. Because if I replace this by 99.7%, how much will, sorry.
3 sigma.
Yeah. If I increase to 99.7%, what will happen to this? This will be 3 into standard error. So now here it will be 3 into this. So it becomes wider, right? So remember this. Given a confidence interval, given a confidence number, if you increase the sample size, the belt becomes narrower. But if I increase the confidence, the belt again becomes wider, given a sample size. Yeah, this 99. This is your confidence, huh? You are this much confident. So why is it called confidence? You see, you know that 66% values lie between mean plus minus sigma, right? You know that. So out of 100 values, 66 will lie in that region. So you are 66% confidence that the interval lies, that the value lies in that region, right? Now, if I want to be 99.7% confident, my intervals will become obviously 3 times wider. Yes. Yes, sample average is normal average on sample. What is this? No, sample average is normal sample average, right? You have 10 observations, take an average. That's it. Because we told na sample average follows normal distribution. If this is true, then this is true, then the whole thing follows. Which probability? Using the Z table? Yeah, you can use the Z table. Say for example, okay, so we know sample average follows this distribution. If I want to convert it to normal 0, 1, I'll subtract the mean divided by standard deviation, and then you can calculate from the Z table. No, what I'm saying is, okay, let's do an exercise, right? Okay, so let's say I'm saying that age, you need to give me interval or say 70% confidence interval for age, right? And I'm telling you the standard deviation, the population standard deviation of age is say 20, right? Okay. Now what do? You go and collect a sample. Let's say the sample gives you a sample average of 30. Can happen? Okay. Now, what do I do with this information? So I know this 30 is coming from a normal distribution which has a mean equal to the population mean and a standard deviation equal to 20 divided by my sample size. Isn't it? Square root of my sample size, right? Say my sample size is 100, right? So 20 divided by 10. So you know this 30 is coming from a normal distribution with a mean that you do not know, right? And a standard deviation equal to 20 by square root of 100, right? So 30 is coming from normal distribution with a mean of that we don't know and a standard deviation of 10. Okay. Now, sorry to yeah. Now yes, what we were saying? How will you use the date table? Okay, so let's say you then 30 minus mean divided by 2 comes from n 0, 1. Okay, so how do you use the Z table? Okay, so what I can do is if I have to calculate this, and I need a 60. Okay. So I'm looking for a 70% confidence interval, right? I don't know whether this will work. Let's try it out, right? So I need a 70% confidence interval. So what I'm looking for is, this is the bell curve. I'm looking for an interval such that within this interval, there is 70% probability. So how much probability will be outside? 30. So this side there will be 15%, this side there will be 15%. Okay. Now what I will do is I will get a point such that to the left of that point there is 15% probability. Make sense? Okay. I mean, I don't know whether this will work. Let's see. Where is the Z table? This is the Z table, right? So I'm looking for a point so that to the left hand side, the area is around 15%. Do you see a point? 15. Where do you see? Left 1492. Okay. So this is how much? Minus 1 point. No, minus 1.01234. Minus 1.04. Make sense? Okay. So we know that area to the left of minus 1.04 is 15%, right? So we also know.
Sir, can you please repeat this? How we came for minus 1.04 through Z map? Z number.
So if you look at minus 1.0 and here you have 0.1492, right? Which is almost equal to 0.15.
Okay.
Okay. So you have 15% to the left of minus 1.04. Okay. So we also know area to the right of 1.04 is 15%. Okay. Now, what do we do with this? What do we do with this? You can calculate mean, right? How do you calculate mean using this? That's what I'm trying to figure out. Okay, so this quantity, so 30 minus mean, 30 minus mean divided by 2 lies between minus 1.04 and 1.04 with 70% confidence, right? And you can get the confidence interval of mean now, right? What you will do is it will multiply both sides by 2, so it becomes minus 2.08. 30 minus mean less than equal to 2.08, and then what happens is I will take a minus, so it becomes 2.08 greater than equal to mean minus 30 greater than equal to minus 2.08, and sorry, with 70% confidence. Yeah, now I'll add 30. Yeah. So this becomes 30 plus, so 32.08 greater than equal to mean greater than equal to 27.9, right? With 70% confidence, right? So this is how you can calculate the confidence interval.
Sir, how did we know that 70% about 70% confidence?
Yes. So let's start from the beginning. I am trying to get to an interval such that within the interval there is 70% probability. Yes or no?
Yeah.
So if within this interval there is 70% probability, how much probability is outside the interval?
1 minus 70.
1 minus 70%, which is 30%.
Yeah. Okay.
So to the left hand side there will be 15% probability, and to the right hand side there will be 15% probability, because normal distribution is symmetric.
Yeah. Okay.
So now I am looking for a point such that to the left hand side of that point there is 0.15 probability.
Okay.
Makes sense?
Yeah.
From Z table, I found out that to the left of minus 1.04, there is 15%. So if this is true, then now since it is symmetric, I can say to the right of plus 1.04, there will be 15% probability.
Yes.
Now I get to the expression from there.
Okay.
Which one? Yeah, so you understood this part, right? 70% in between, so 15% here, 15% here, right? So now I'm looking in the Z table for a point which has 15% probability to the left. So I'm looking for a 15% here. This is very close to 15%. So this is minus 1.04. That's how I got. Okay, so now all of you understand this? Yeah. Yeah. Not decrease the sample size. I mean, you don't have to decrease, right? So if I want a 99.7% probability given the same sample, my point was the interval. Yeah, my point was my interval will be wide. If I now want to decrease that interval, I need to increase my sample size. Right? There are two factors at play. I know by increasing the sample size, my interval becomes narrow. But if I increase my confidence, my interval becomes wide. So for example, if I tell you now, this is actually used to calculate the sample size required. Now, if I ask you that give me a 99.7% confidence interval, right? But that interval that you give should not have a range greater than 5. You understand? You understand what I'm saying? So give me a 99.7% confidence interval, but that belt that you give should not be wider than 5. That you can use here to back calculate how much sample size should you use.
Not greater than 5 means the probability shouldn't be greater than.
No. I'm saying that the width. So this range, this is a range, right?
Right.
This range should not be of a width greater than 5. If somebody gives you something like that, you can always use this expression to back calculate how much sample size you need.
Okay.
Right? Because see, you have to get the population mean, right? I have told you 99.7. So you know that it has to be 3 into standard error, right? So now, how can you reduce the standard error? So put in different values of n and see for which value of n you get a width of 5. Yes. The belt becomes wider. Yeah, as a result, the belt becomes wider. So, I mean, let's do this, right? Say, for example, if I need 99.7% confidence interval and the sample size should, or the interval should not be more than 10. Let's do an example. Let's do it here. Let's say I have given the sample average. Okay. Let's say the sample average is 10, right? Let's take a hypothetical example. Now, if I tell you the sample average is 10, you know what you can calculate, and you know population standard deviation. Let's say population standard deviation is 20. Can you or can you not find a value of n such that the difference between these two is 5? You can find, right? Okay. Now, in a real scenario, you will know the population standard deviation, but you obviously will not know the sample size because you have not calculated the sample size, right? You have not calculated the sample, na? You want to find the sample size, which means you do not have the sample. So you will not know this quantity.
Sir, what your question is to get the 99.7% probability
No,
of occurrence?
my question is how this expression can be used. This expression can be used in multiple ways. One of the ways that this expression can be used is to find out how much sample size is required to get to a confidence interval and still have a very narrow belt. Right? So what you will do is you will have to create some sort of optimization which can interval different values of sample average and gives you what sort of populations or what sort of size you will need. Right? So it can tell you, given this is the sample average, this much should be the size. This is the sample average, this much should be the size. So you can look up, you have a sample, you calculate the sample average, and then you see, is my sample size enough to get a 99.7%? No. Then you again recollect the sample. Right? But I mean, don't go into that, but this expression can also be used to calculate the sample size, but we will only use it for the confidence interval to estimate population mean. That's our use, right? But this has other uses also. Okay, now forget about the thing that I talked about, sample size calculation. Is the central limit theorem clear? Yeah.
Yes.
Mm-hmm. No. When I say sample average of 100 equal to 30, sample average is of 30, sample size is 100. One sample, no? One sample which has 100 observations, because I wanted to demonstrate that if you plot those 10 samples, it would have become a bell curve. But now we know it will be a bell curve, right? Now we can deal with only one sample. Yeah, but I mean, I don't want to draw the curve right now, right? I know it is a bell curve, so I can deal with one sample. If you want to draw the curve, I'll need multiple samples. Yes. Yes. Okay. Now, any questions on this? All of you are clear on this? Okay.
So, sir, basically in central limit theorem, you can say average of sample is equals to population, average of population, right? And it will be well curved.
No. Why did I say that? I never said that. In central limit theorem, it means sample average follows a distribution which is normal, and that distribution has a mean equal to population mean and a standard deviation equal to population standard deviation divided by square root of n. See, this is all about distribution. See, the thing is that you are calculating sample average based on a small number of observation. The population is really large. Now, what this central limit theorem does is it tells you that even if you get a single sample, right, it is coming from a portion of the population, right? So that sample shares certain properties of the population. What is that property? The property is, if you collect multiple such samples and plot those samples, you will get a bell curve such that the bell curve will have a mean equal to population mean and a standard deviation equal to standard error. Frequency of the average of the sample. मतलब क्या उसका? Frequency of the average. Correct. Okay, so what you do is you get a frequency plot of the average that you get from the sample. Correct. Okay, any questions? Now, let's do one exercise which should be here. Okay, I think there are no examples. Okay. Any questions on interval and point estimation? Now, just to summarize the things that you need to remember from here. One, estimation, point estimation, right? Point estimation, you just need to remember two things. If somebody asks you to estimate population mean, it will be sample average or sample mean, right? If somebody asks you to estimate population standard deviation, it will be sample standard deviation. Okay. Now, interval estimation. Interval estimation comes from central limit theorem. Central limit theorem states that average from a sample follows a normal distribution with a mean equal to population mean and a standard deviation equal to standard error. What is standard error? Standard error is population standard deviation divided by square root of n. Make sense? Just remember these 4 lines, it should be fine. Just these 4 lines, right? And if you combine with these 4 lines the properties of normal distribution, you can get the interval estimates, right? Okay. Any question? Cool. So now we'll go for a break. After the break, what we are going to do is we'll start with a concept known as hypothesis testing. Hypothesis testing, right? Now, before we go into hypothesis testing, any question on point and interval estimation? Yeah, estimation you will only do for the population. No? I mean, what else can you do? You have a sample, you use that to draw estimation on population. That's it. If you want to use the sample to infer about population, yes. Yes. Yeah, so population means, say, if I want to analyze, say, male, right? Then all male population in the world is my population. If I want to analyze cars, all cars in the world is my population. Population is subjective depending upon what you are trying to analyze. Now, hypothesis testing, right? Hypothesis testing also talks about inferring about population, right? So, in point or interval estimation, what were we trying to do? We were either trying to get a pointed value of a parameter, or we were trying to get an interval value of the parameter, right? These are the two possibilities, either pointed value or interval value. Hypothesis testing has a bit of difference, right? Now, in hypothesis testing, what we try to do is we try to validate our preconceived notion. Now, what do we mean by that? Now, let's understand what kind of business question can come. So, one kind of business question that can come is, tell me average age of all customers. right? This can be a business question. The answer here will be point estimation. You will take a sample, estimate the average of the sample and give the answer. Now, second kind of question is, give me a 80% confidence interval for average basket size. Basket size basically means how much money does a typical customer spends on a single trip, right? So give me a 80% confidence interval of for the average basket size, right? What kind of estimation will that be? Interval. Third question. Validate if average income of our customers is equal to 10,000 rupees per month, right? If you get a statement like this, then this is a preconceived notion that you want to test, right? What is the preconceived notion? Preconceived notion is this particular line, right? This is a preconceived notion that somebody in the business has, right? And you need to validate whether this is true or false. Make sense? These are the three kinds of questions that can be answered either by point estimation or interval estimation, and the third one is answered by hypothesis testing. Basket size is the amount of money that a customer spends on a single trip. Okay. Now, hypothesis testing, right? So hypothesis testing, there are few things that are mandatory in a hypothesis testing framework. The first thing that is mandatory is that preconceived notion, because that's what you are testing, right? So that preconceived notion is known as null hypothesis and is represented by H0. The preconceived notion is known as null hypothesis and is represented by H0. H0, now remember this carefully, H0 will always have a format similar to this: parameter value equal to a value, or parameter equal to a value, right? What do we mean by parameter equal to a value? It will always be something like whether the average is equal to this or the average is equal to that or something. Null hypothesis cannot be greater than or less than or not equal to. It has to be equal to a value. So you cannot test the preconceived notion that the average income of our customers is greater than 10,000. You cannot test that as a null hypothesis. Okay. Now, apart from null hypothesis, there is another hypothesis which is known as alternate hypothesis. Now, alternate hypothesis is something which you test against null. So you are saying either null is true or this is true, right? Alternate hypothesis can have parameter greater than that value or greater than that value, or it can be parameter less than that value, or it can be parameter not equal to that value, right? Alternate hypothesis can be greater than or less than or not equal to any one of this, right? What you choose as the alternative depends upon what the business wants to test for, right? If, for example, here the business just want to test if the average income is 10,000 or not, right? Here the business, what does the business want to test? Validate whether the average income of our customer is 10,000 per month or not, right? In this case, what will be my alternate? Not equal to, right? But if the business wants to know, test if average income is greater than 10K. Your null hypothesis will still be average is equal to 10K, but the alternate becomes average greater than 10K. Make sense? So I'm saying that the choice of alternate depends upon what the business is asking you. If the business asks you that test if the average income of our customers is greater than 10K or not, your null hypothesis will be average value equal to 10K. Alternate will be average greater than 10K.
Or less than 10K.
Make sense? Parameter is
Greater
a
than,
population parameter, average, yeah.
say it would be both, right? Greater than 10K or less than 10K.
No, you can test only one alternate at a time.
Sir, in the null hypothesis, equals to or not equals to in the both category.
Null hypothesis can only have equal to sign.
Okay.
Alternate can have greater than, less than, not equal to sign.
Okay.
Okay. Now, depending upon what your business is asking you, you will choose the alternate accordingly.
Sir, did you give any example where first and second point both are used?
Sorry?
Null, I'm asking that, did you give any example where null hypothesis and alternate both are used?
For every hypothesis testing, you will have to choose the null and one of the alternates. So I am saying that both of them have to be chosen, right? You will have a null hypothesis and you will choose one of these three possible alternates, depending upon what is the business question.
Okay.
So can you give an example, please?
I will come to an example now. Third one, right? So third thing that is required is something known as test statistics. Fourth one that is required is distributional assumptions. Fifth one that is required is known as significance level. Sixth one that you require is the p-value. These are the 6 things that you require in any hypothesis testing, right? Now I will explain the last 4 as we go ahead, okay? Now, hypothesis testing is very similar to a court case, right? You have heard of or seen court cases in television, right? So it is very similar to that. Now, in a court case, what is the null hypothesis? Null hypothesis is a person is not guilty. You see, in legal terms, you are not guilty until proven guilty, right? You're innocent until proven guilty, right? So the null hypothesis will be innocence. The alternate, on the other hand, will be not equal to innocence. Makes sense? Every court case, you test this null hypothesis against the alternate. Now, how does the judge decide whether the null is true or the alternate is true? Basis some proofs, right? The equivalent of proofs here is this test statistic, right? This will act as the proof. Now we'll understand how, okay? Now, once given the proof, what does the judge think? The judge thinks that he first assumes that a person is not guilty, right? Then he tries to find out, assuming that the person is not guilty, what is the probability of having this proof. Now, for example, let's say in one particular case, one of the proofs that you get is a knife with the guilty person's fingerprint and it has the blood and all of that, right? Now, if the judge is presented with the proof, what he thinks is, what is the probability that the person is innocent, but this proof can be present? If that probability is really low, that means that the person is not innocent. Makes sense? Right? So what is the probability that a person has not murdered somebody, but his fingerprint is present in the knife has blood of the victim, and somebody has also seen that guy putting that knife inside that person, right? That if that probability is really low, right, then only the judge decides that the person is not guilty. Makes sense? Okay. The equivalent here is, we will have the test statistics, which is the knife, right? And the distributional assumption is basically assuming that the person is not guilty, right? What we will do is, under the assumption that the person is not guilty, we will find out what is the probability of getting the value of this statistic. Statistics means a calculation, right? We'll calculate something on the sample and then figure out what is the probability of getting the value that we have got, assuming that the null hypothesis is true. If the probability is really low, it means the null hypothesis is not true. Same as the court case. Okay, now hold your thoughts still here. So now we go into an example. Now, take some time to read these 3 lines.
So if probability is low, then null hypothesis would be true.
Okay,
right?
you think if a person has stabbed somebody and the probability of him being innocent after stabbing somebody is low, then the judge will pronounce that person as innocent.
So we are taking it initially as a null hypothesis, right? We are going to make it false.
Under null hypothesis, the number that you have calculated has a very low probability. That means null hypothesis is not true, na? If the probability of a person having fingerprint on the murder weapon even after being innocent, if that probability is very low, it means that that person is not innocent.
Right.
Yeah, so that's what I am trying to point out.
Okay.
Okay. Now, all of you have gone through these 3 lines. What does it say? It says that the government of Melbourne assumes or has a notion that the average petrol price is around 92 cents per liter. Right? And in order to test that, they take a sample of 50, right? And they found out that the mean is 93.6. Makes sense? And what is also given is the standard deviation is 3.1. Okay. Now, what is my null hypothesis? Null hypothesis is, so there are 6 components to a hypothesis testing. Always remember this, right? First component is null hypothesis. Null hypothesis is mean price, obviously. So let's say average price is equal to 92 cents per liter. Okay. And alternate is average price. So imagine, what is the government trying to test? Government wants to know whether indeed the petrol price is 92 or more than that. Because if it is more than that, then there is some problem. Imagine from the government's perspective, right? If it is more than that, then it is problem. If it is less than that, the government will not have any problem, right? So actually, the alternate is average price greater than 92. Right? Because you have to understand what is their interest. A government would always want the petrol prices to be lower than they're expected, right? Or at least equal to what they expect, not higher. Make sense? Okay. So the alternate here, which is the second component, is average price greater than 92. Now comes the third component. Now the third component is test statistics, right? Test statistics, I mean, it's a fancy name for a calculation, right? We'll calculate something on the sample and we'll call that as test statistic, right? Now, what we have on the sample, we know that the sample average is how much? 93.6, right? What we also know is population standard deviation is how much? 3.1. 3.1. This is the information that we have. Now, how do we know what should be the test statistic? Now, if you look at the problem, it says petrol prices are normally distributed. Make sense? Okay. What we know from the central limit theorem, sample average follows normal distribution with a mean equal to population mean and a standard deviation equal to population standard deviation divided by square root of sample size. Now, what is the sample size here? 50. Okay, all of you are fine with whatever I have written? All of you are fine with that? Okay. Now, basis this, can I write that, or basis this, can I write, or, okay, now what we will do is, we will assume the null hypothesis to be true, right? So if the null hypothesis is true and petrol prices are indeed normally distributed, what can we see? Petrol prices will now have a bell curve to follow, right? And the bell curve is centered around 92 according to null hypothesis, right? Now, according to central limit theorem, the sample average also is a bell curve, which is centered around again 92 under the null hypothesis. All of you are clear? Okay. Now, what I now do is, I will now plot this 93.6 in the bell curve. So 93.6 will, let's say, somewhere around here, right? What I will do is, I'll calculate the area to the right of this line. Now, what is this area? This area to the right is the probability of getting a value greater than equal to 93.6. Make sense? If this probability is very low, it means that getting a value of 93.6 with a mean of 92 is highly improbable. If this area, what is this area? This area is getting a value greater than equal to 93.6. Now let's say this area is really small. What will that mean? That means that under the null assumption, getting a sample average of 93.6 is highly improbable. Yeah? Yes or no? This, if this area is low, it means it is highly improbable, right? So now going back to the court case example, right? What happens? So this sample average is a proof that you have been presented, right? And you are saying under the null assumption, this proof is highly improbable. So what does this mean? My null assumption is not correct. Null assumption is not correct. If under the null assumption, the existence of the proof is questioned, proof to I already have. Null is an assumption. Then my assumption is not true. Proof I have calculated from data. Assumption is what I have assumed. Data is hard, right? You cannot change data. What you can change is the assumption. So if the data says your assumption is under the assumption this data cannot exist, it means your assumption is false, because data is absolute. Data is what you have seen. Assumption is something you assume. Makes sense? For example, if you assume somebody is blind, and if you saw him walking on the road, casually crossing the road, right? Casually crossing the road you have seen, right? But your assumption was he was blind. Then probably your assumption is not correct, right? Because what proof is absolute. So similarly, average you have seen. If this average is highly improbable under the null hypothesis, that means null hypothesis is not. Make sense? Okay. How do you calculate this? So we know central limit theorem, right? So under central limit theorem, 93.6 should also have a normal distribution with a mean of 92, right? Or in other words, 93.6 minus 92 divided by 3.1 by square root of 50. This follows normal 0, 1. Yeah. Okay. Now, if I know that this follows normal 0, 1, can I find the area to the right of this quantity? Yeah. So first, let's calculate what is this quantity. This quantity is, just go to Excel. So it's 93.6 minus 92. This one divided by 3.1, right? 3.1 by square root of 50. So 3.64. We want to calculate area to the right of this, right? So we want to calculate probability that x is greater than equal to 3.64, which is equal to 1 minus probability x less than equal to 3.64. Yeah. Okay. Now, if you go to the Z table, remember Z table ended at 3.4. So what is area to the left of 3.6? 1. Okay. So this becomes 1 minus 1, which is equal to 0, right? Now, what do you conclude from this? That the area to the right hand side is 0, right?
Sir, so just a sec. How did we conclude it? 1 minus 1. That hair quality will be area would be.
Area to the left of 3.4 is 1, almost
Okay.
1. So the area to the left of 3.6 will always also be 1.
Yeah, got it.
So this will be 0, right? So getting an average of 93.6 is really improbable. Make sense? Right? So you, the judge, now know that the null hypothesis being true under the proof that you have, the probability is really low, right? Now, next comes, so the distributional assumption though we already have from the central limit theorem. Distributional assumption here is normal, right? So what is the distributional assumption? Normal. Normal why? Under central limit theorem, right? Fifth one is significance level. What is significance level? Significance level tells you how low is low. So you might say a probability of 0.5 is low. I might say a probability lower than 0.3 is low. Somebody might say something different, right? There has to be universally accepted norm. Significance level is that norm. Significance level is usually taken as 0.5 or 0.05 or 0.01. So it is either 5% or 1%. For now, in the context of this course, we will always use 5%. Okay, so forget about 1%, we'll always use 5%. So whenever the probability is less than 5%, we will reject the null hypothesis. Now, what is p-value? P-value is basically the probability that you have calculated. This is known as p-value. P-value, if you want to define p-value, it is the probability of getting the value of a test statistic at least as high as what you have got. Now, what did I say? P-value is the probability of getting the value of test statistic at least as high as you have got. At least as high means probability of getting a value greater than equal to what you have got. At least as high means what? Greater than equal to that value, right? That's what we have calculated here, right? We got a test statistic value of 3.64. Remember, we calculated probability of getting at least 3.64, right? So what is p-value? P-value is probability of getting the test statistic at least as high as what you have got. It is the textbook definition of p-value. Okay. Now, if this p-value is less than your significance level, you will reject the null. If this p-value is greater than your significance level, you will accept the null. So forget about these 6 things, right? The only thing that you should remember in hypothesis testing is one particular line. What is that one particular line? If p-value is less than 5%, reject null. That's it. That's it. This is the only thing that you have to remember. Everything else will be taken care of by the software. 0 is the p-value. My significance level is 5%. So is it less than 5%? Yes. So what is your conclusion? Average price is not 92. %5 is a absolute value, probability. Yeah. In this course, yes. In the industry, it is either 5% or 1%. No, you will say average prices is greater than 92.
What if petrol prices are not normally distributed?
It doesn't matter, right? Till the central limit theorem is valid. The central limit theorem is valid irrespective of normality or non-normality, right? Yes. That was it. Make sense? Okay.
Sir, I have a question.
So, I mean, so our distribution assumption is taken care of here because you see we use central limit theorem, right? Under central limit theorem, what is the distribution? Normal. So that's why here in this particular case, the distribution of the null hypothesis will be normal. That's it. So it actually the whole thing is taken care of in this 3 lines because we directly use CLT, right? So the distribution assumptions also come, the test statistic also come with it, and the p-value also comes with it.
Sir, in the test statistics.
1 second, I'm coming to the online question. Sorry, what were you saying? No. Here also I'm checking. I'm saying that in our case, we know the distribution will be normal because of CLT. If we were testing for something else, we will use some other theory. That will also tell us what will be the distribution. Yeah. Yes. What was the question online?
Sir, on alternate hypothesis can be used more than one. I mean,
No,
currently.
alternate hypothesis only you can test one at a time.
Sir, in the test stat, what is the 3.64? As in, what do we call that value?
So 3.64 is the value of the test statistic. So see, it is coming from central limit theorem, right? You
What is this
understand?
value called? When we refer to the Z tables, what value do we calculate that we refer to the Z tables?
You calculated 3.64, right? And you look for 3.64 here in the in this axis of the Z table.
But what is it called? This 3.4, 3.3, what is it called?
These are normal values.
Okay.
These are values of normal distribution. Okay.
So, sir,
Yes.
if null hypothesis is rejected, we are going to check for alternate, like either it is greater than 92 or less than 92, both, right?
No. Right now, you are only checking for greater than 92. That's what I'm saying, right? You will check one alternate at a time. If I'm checking for greater than 92, I will only check this. If I'm just checking for less than, I'll only check that. If I check for not equal to, I will check for not equal to.
We
Sir,
have to check with both.
Sorry?
In the third point test start, can you explain 93.6 minus 92?
Okay, so if I know sample, what is central limit theorem? What is central limit theorem? Central limit theorem says that sample average follows a normal distribution with a mean equal to population mean and a standard deviation equal to standard error, right?
Yeah.
Okay, so that means 93.6 is coming from a normal distribution with a mean of 92 and a standard deviation of 3.1 divided by square root of 50. Yes or no?
Yeah. Okay.
So if this is true, then I can write this as well, right? So I just subtracted the mean and divided it by standard deviation. So it becomes standard normal.
Okay.
Sir, sample size is coming 50 from where in the question it is mentioned?
Yeah, in the question it is mentioned 50. Sample of 50.
Okay.
What it is zero? Probability is zero. Yeah. So probability is zero means what? Under the null assumption, probability of getting a value of 93.6 is highly improbable, right? Probability is very small means highly improbable. So you reject the null. Yes. Okay. So look at this line. 93.6 comes from a normal distribution. You agree with this? No, you are in agreement with this line, yes or no? You are agreement with this line. Okay. So when I calculate this probability, you are in agreement with this probability? Okay. Now, this probability is equal to zero basically means probability, say if this is 93.6, it means that probability to the right side of 93.6 under the mean of 92 is zero. Because here you see, here you see normal mean is 92, right? Under this mean, that probability is very small. That means this mean is not true, right? Irrespective of the distribution. You can do this, provided you know population standard deviation. No, central limit theorem तो always it will land you up in normal. Central limit. हाँ, अगर आप सेंट्रल लिमिट थ्योरम अप्लाई कर पाए तो कुछ कुछ सिनेरियोज में नहीं कर पाओगे, उसमें हम कुछ और डिस्ट्रीब्यूशन देखेंगे. टेस्ट स्टैटिस्टिक यहाँ पे आपने सैंपल पे कैलकुलेट किया एंड अंडर दैट सिनेरियो डिस्ट्रीब्यूशन विल नॉट बी नॉर्मल. फिर हम कुछ और थ्योरी यूज करेंगे. हाँ, now let's say forget about this this alternate, right? Let's see if I want to test whether it is less than 92, right? Now instead of area to the right, now we will calculate area to the left. Make sense? Because whenever I am testing for greater than, I will calculate area to the right. Whenever I am testing for less than, I will calculate area to the left. So area to the left will be how much? 1. Which means what? Which means my alternate is not true. See, there is a technical jargon that is used here, right? So whenever you get a result of any hypothesis testing, you will never say that the null is true or null is false. What you will say is, we reject the alternate under a significance level of 5%, or we were not able to reject the alternate under significance level of 5%. Just to be technically correct. Either you were able to reject or you were not able to reject. You will never say this is true or that is true. This is to, save your own back actually. Because later on, because it is all probability, right? Later on, if you are extremely unlucky and the whatever you said came out to be false, then the business will be after you, no? So we never say something is true or something is false. We will say yes. We will say either we are able to reject or we were not able to reject. No, it means, but we'll not say that.
Statement, we are only looking at alternate.
Yes, forget null, only alternate. Because in business, null is fixed. Null will always be parameter equal to a value. Alternate is chosen based on the business priorities. So business will be more interested in the alternate. So you either reject the alternate or not reject the alternate. No. Not reject means not reject. Because this is probabilistically, right? You cannot accept a value. You are saying that I am not able to reject this under 5% significance, which means there is a 5% probability that the alternate is true. You don't get it, right? ये थोड़ा confusing है. तो इसमें क्या होता है? आप ये बात को समझो. This is probability. Now probability is something which is very dangerous. You cannot say something with certainty, right? In our world, everything is binary. You are certain or you are not certain. In numbers, it is probabilistic. So what we are doing is, say we have got a test statistic value which is here. We are calculating area to the right, and we are saying if this area is less than 5%, then we will say that we will accept or we were not able to reject the null, right? If it is less than 5%. Now less than 5% might mean 4.9%. What does this 4.9% signify? This 4.9% signifies that there is a 4.9% chance that the alternate should be accepted. And there is a chance 4.9%. So we will never say absolutely reject, because there is always a chance. We are dealing with probabilities here, right? Yes. Yes, it's there. Because that's why we are saying that if the chance is less than 5%, then we will reject. But less than 5% does not mean zero. Yes. Because you think you understand normal distribution goes from minus infinity to plus infinity. The only place that area to the right will be zero is infinity, which you will never have. So area to the right will always be greater than zero. It might be very small, but greater than zero. Okay, now do you understand this technical thing, right? So you will say either you reject the alternate or you were not able to reject. Yes.
So, sir, in this example, we were not able
At that point, we will consider this as a normal distribution under CLT. I mean, see, although I've written it as 1, 2, 3, 4, and so on, they are not disjoint steps, right? They'll come together. I would have written it point-wise because it's easier to remember. Everything will come together. Given a scenario, you will basically use one of the theories that you know, and then the distribution assumption, the test statistic, everything will fall into place.
The statement, why do we write significance level of 5% when the probability that we calculated is under 0.01%?
Yeah, because we will always refer to the significance level. We'll never talk about distinct probabilities. We will say that significance, we reject this under a significance level of 5%.
But the probability that we calculated of actually getting 90.
The probability will change if I change one observation. Right? So you take a level. You do not quote the probability. You understand probability is absolutely dependent on the sample that you have drawn. Right? If the sample, even one of the observations in the sample change, the probability will vary minutely. So what will happen is if you quote the probability, now you are saying 0.001, next day you are saying 0.002. To every time your probability will change, which will cause confusion in the business. So you take a significance level and stick to that. You will say it is less than 5%.
Okay.
Sir, we took null hypothesis as price equals to 92. And alternate hypothesis we took as price greater than 92. So does the greater than or smaller than sign make some difference in alternate?
We are not. That's what I'm saying, right? We are not checking for normal distribution. What I'm saying is, although I've written these steps differently, right? These are not different steps. They come together. So as soon as I know that I can use CLT, I know what is my test statistic. I know what is my distribution. They come together in the same step. I have written them in different steps doesn't mean you have to use different steps to do them. These are the components which build the you see the scenario, right? It talks about sample average. So on sample average, what all theory do you know? CLT. So we'll use that. Okay. Yes. What was the question from online? There was one question from online.
Yeah. So, sir, in this particular case, we have rejected the null hypothesis.
No, in this particular case, we were not able to reject the alternate.
Okay.
Sorry. Yes, we were not able to reject the alternate. Yeah.
And so one more question. We took price as equals to 92 for null hypothesis. For alternate, we took price greater than 92. So that greater than sign is dependent on the sample average value of 93.6.
No, that the greater than sign is dependent upon the business. The business will tell you what they want to test.
Okay, and if it is greater than or lesser than, then how does the calculation differ?
I mean, I'm coming to that. All of you are, you understand what we have done here? Okay, now instead of greater than, if I make it less than, right? Now let's again plot the distribution. The distribution under null hypothesis remains same, right? So it is still a normal distribution with a mean at 92. I've got a sample size of 93.6, right? Now, if I am testing an alternate of less than, I will calculate area to the left, right? And if this area is less than 5%, I will reject, or I will not reject the alternate. If this area is greater than 5%, I will reject the alternate. Same thing, right? So one thing to remember. One thing to remember, p-value greater than 5%, reject the alternate, right? How we calculate p-value? If it is a greater than case, it is area to the right. If it is less than case, it is area to the left. Make sense? That's why the greater than test, the greater than alternate is known as right-tailed test, because you calculate the right tail. The less than alternate is known as left-tailed test, because you calculate the left tail. Clear? Okay. Now, the last alternate which is still remaining is the not equal to, right? Now, not equal to, we deal it in a different way. So you are able to digest this, right? I don't want to cause a indigestion right now. I mean, you are able to digest this, right? हाँ तो थोड़ा हो रहा है तो you tell me ना.
So when we check for less than 92, how will the equations change?
Yeah, so instead of greater than equal to 3.64, you look for less than equal to 3.64, which will be exactly equal to something close to 1.
Right.
You were doing x minus mean upon standard deviation, and then the value was
Standard normal.
given over in the table.
Yeah.
Today we did the same, but the difference was we divided that standard deviation with a square root of sample size.
Why?
Because we had a sample size as well here.
No. Why did we do that? Because the normal distribution here has this whole thing as standard deviation. Huh? This is the standard deviation. We did not do anything different. This normal distribution has this standard deviation. No. You don't understand. So there is a normal distribution with a mean of 20 and a standard deviation of 2. If you want to convert that to a standard normal, you subtract 20, divide by 2. Make sense? There is another normal distribution which is a mean of 20 and a standard deviation of 1. So you subtract 20, divide by 1. I just did that. So this one has a mean of 92 and a standard deviation of 3.1 divided by square root of 50. So I subtracted the mean divided by standard deviation. This whole thing is the standard deviation under central limit theorem. So I am doing the same thing, exact same thing. In that case, we had the standard deviation as a whole. Here, the standard deviation looks like this. Okay. Now,
sir, can you please explain the about two statements?
Which two statements?
We reject the alternate under a significance level of 5%, and we are not able to reject the alternate under the significance level of 5%.
This is how you will state the result, right? So if the p-value is greater than 5%, you will say that you were able to reject the alternate with a significance level of 5%. If the p-value is less than 5%, you will say that you were not able to reject. This is how you frame the answer. Now, next. Now the only thing or the only alternate that we have left is the not equal to part, right? Now, how do we deal with not equal to? So not equal to means it can be greater than, it can be less than, right? It can be both actually. So this is known as two-tailed test. Greater than is right-tailed, less than is left-tailed. This is two-tailed, right? Now, how do we calculate or deal with this two-tailed scenario? It's very similar, but we approach it in a different way. What we will do is we will build something known as acceptance region. What is acceptance region? Acceptance region is that region such that if the test statistic lie within that region, you will reject the alternate, right? So for example, so how do we get to this region? So you remember what is the significance level? 5%. So we will only reject the null hypothesis if the test statistics lie at a point which is in an area which is 5%, right? Now, a normal distribution is symmetric. So if I want to build an acceptance region, the acceptance region should have how much probability in it? 100 minus 5, 95%. I will build that acceptance region. So I will get a region such that within that interval there is 95% probability. Make sense? I am approaching it from the reverse, right? Previously we were calculating the area to the right or left. Now here it becomes complex, right? So what we do is we'll take the easy way out. We take when can we accept? When can we accept? We will accept if it will fall in a region which has 90% of the 5% of the probability in it, because my significance level is 5%, right? So I plot or get an area which or get a range that can contain 95% probability within it, right? Now how do I get it? So what are the information that we have? We know sample average, population standard deviation, and sample size. We know these three, right? Now what we also know is this 93.6 comes from a normal distribution which looks like this, right? Okay. Now the first thing that we do is we go to standard normal and figure out this range, right? In standard normal, we are looking for a range such that within that range there is 95% probability. That means what? How much area to the is to the left of this? 2.5%. And how much area is to the right of this? 2.5%. So basically we are looking for a point which has an area of 2.5% to the left, right? So we will go to the Z table and look for a point which has 2.5% as probability to the left. So 2.5% will be 0.025. Minus 2. Achha, minus 2.8, 0.025, yeah. 2.81, right? Minus 2.81. So this is 0.00. Now we are looking for 0.02. This is 0.002. This is 0.25%. I'm looking for 2.5.
Minus 1.96.
Yeah, see. So this is 9, 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, right? So this is minus 1.96. So now going back to this, we know in a standard normal scenario, probability to the 1.96, probability to the left of minus 1.96 is 0.25. Make sense? Okay. So we will also then know probability to the right of 1.96 is 0.25. All of you agree with this?
No,
Yes?
sir, it's 0.025.
Okay, yeah, 0.025. Yeah. Okay. Now, I will now go from standard normal to the normal that I need. How do I do that? We know from how to convert from any normal distribution to standard normal. I will just reverse that transformation. Okay. So what is the population standard deviation? 3.1 by square root of 50. So what I will do is I'll calculate 3.1 by square root of 50. It is around 4.44, right? 0.44. Okay. So what I will do is, if the above two statements are true, I can say that probability minus 1.96 into 0.44 minus, sorry, plus 92 greater than equal to average price less than equal to 92 plus 1.96 into 0.44 plus 1.96 with 95%. I can say this, right? So what will happen to my interval? My interval now becomes 92 plus 0.4 into minus 1.96, minus 1.96, right? 6 and 92 plus 0 point this into 1.96. Yeah, so this becomes my interval. So my acceptance region now becomes between 91 point something to 92 point something, right? What is the sample that I've got? 93 point something, right? So it is outside the acceptance region. So now what I say is I am not able to reject the alternate hypothesis with 5% significance. Not reject the alternate. Makes sense? Okay, now what did I do? First, I found out what is my significance level. My significance level is 5%. If my significance level is 5%, when will I accept? I will accept in a region that encapsulates a probability of 95%. Now, what I then did was I went to standard normal and found out for standard normal what is the range that will have 95% probability in it. That range is from minus 1.96 to 1.96. We found it from the Z table. Now this is in standard normal, right? I have to reverse it back to the normal with mean 92 and a standard deviation of this. How do I do that? Multiply by standard deviation and add the mean. Because I do the other way around when I convert it from this to the standard normal. To back. Huh. वो जो कैलकुलेशन हमने किया था उसको उल्टा कर दिया मैंने। नॉट एनी नॉर्मल टू स्टैंडर्ड नॉर्मल कैसे जाते हैं? वैल्यू से मीन सब्ट्रैक्ट करते हैं बाय स्टैंडर्ड डिविएशन। अभी स्टैंडर्ड नॉर्मल से यहाँ पे आना है तो क्या करेंगे? स्टैंडर्ड नॉर्मल के साथ स्टैंडर्ड डिविएशन मल्टीप्लाई करेंगे और मीन को ऐड कर देंगे। वही तो किया है, वो किया तो मेरे को क्या मिल गया? एक्सेप्टेंस रीजन इन दिस डिस्ट्रीब्यूशन। अभी ये जो वैल्यू हमको मिला है ना, ये वैल्यू एक्सेप्टेंस रीजन से बाहर पड़ता है, तो हम एक्सेप्ट नहीं कर पाएंगे नल को। नल को एक्सेप्ट नहीं कर पाएंगे। नल को एक्सेप्ट नहीं कर पाएंगे मतलब क्या है? ऑल्टरनेट को रिजेक्ट नहीं कर पाएंगे ना, है ना। नल को एक्सेप्ट नहीं कर पाएंगे तो हम ऐसे तो बता ही नहीं सकते नल को एक्सेप्ट नहीं कर पाएंगे। हम क्या बताएंगे? ऑल्टरनेट को हम रिजेक्ट नहीं कर पाएंगे, ऐसे बताएंगे। ये सॉरी सर, यू आर सेइंग समथिंग। हाँ, the value you have got is 93.6, which is outside. You will say that you will not, you are basically not able to accept the null, na? So we will not say we are not accepting null. We will say that we were not able to reject the alternate. हाँ हाँ हाँ।
So I have a one question.
हाँ, मतलब you don't want to hurt that person's sentiment, ना? Yes, sorry. What was the question from online?
So can you show the calculated values in the Excel?
Yeah, sure. So in Excel, what I did was I calculated the following things.
Okay. Okay.
Okay, so this is basically the crux of hypothesis testing, right? Now, depending upon different scenarios, the test statistics will keep on changing, right? We will not go into such detail for every scenario. This is the simplest scenario. That's why we broke it down and look into the inherent steps. For rest of the hypothesis testing, we will only know what test to use, right? Rest will be taken care of by Python, right? What Python will do is it will ask you what test you want to do. You mention the test, Python will throw out a p-value. Now, based on the p-value, you decide whether to reject the alternate or not reject the alternate. Make sense? So that's why only one per line is important here, which is, yeah. So if the p-value is greater than 5%, reject the alternate, right? This is the only thing that you need to remember. If you think that everything that we discussed here is too complicated, you do not need to remember this, right? However, during the interview, if you write that I know hypothesis testing, they will get into this, right? So it's your call. Either you tell that I know this in and out, then they'll get into this, or you say that I know how to use it, then they will only expect you to know this line.
Sir, in the line P minus 1.96, from where it is getting the value of probability of minus 1.96?
Minus 1.96.
Sir, it is the probability value, but I am asking minus 1.96 is from where getting?
Sir, here na, look na, minus 1.9, minus 1.9, 1, 2, 3, 4, 5, 6.
So this is the probability value.
Okay, how did we get minus 1.9? Oh, okay.
Yes.
Minus 1.9. So basically we are looking in the standard normal distribution and we are trying to find a point such that to the left of that point, we have an area of 2.5%, right? So we go to the Z table and we look at all these numbers and we found there is a number which is very close to 2.5, which is this. right?
Okay.
It's very close to
Okay.
2.5%, and this
Yes.
corresponds to minus 1.96.
Yes. Okay. And there's another question.
Sorry?
Another question in the notepad. Can you please open the notepad? Sir, this one line, 95% confidence. Before the 95%, could you please brief it? Minus 1.96 into 0.
Yeah. So 0.44 is 3.1 divided by square root of 50.
Yes.
And then I add the mean to it.
Okay.
So I am going from standard normal to a normal distribution. So you
Okay.
know how to go from this distribution to standard normal, right?
Yes.
How do you do that?
Sir, above example we had done.
Yeah. So how do you do that?
Firstly, for the checking for the signal level, significance level and the test
No,
statistics.
I'm saying that if I have a normal distribution with a mean of 92 and a standard deviation of this,
Yes.
how do I convert this normal distribution to a standard normal?
CLT theorem, sir.
No, sir, not CLT theorem. I subtract the mean and divide it by the standard deviation.
Okay.
Not okay. Not okay at all, sir. You need to remember these things. Yesterday we talked about this, na? If x follows n, mean, comma, standard deviation,
Yes.
then x minus mean divided by standard deviation follows normal 0, 1. We discussed this, na, sir?
Yes. Yes, sir.
Yes. So this is how you go from any normal distribution to standard normal.
Yes.
Yes. Now I know this limit for standard normal.
Okay.
I need to go from standard normal back to a distribution. How do I do that? I multiply with standard deviation and add the mean, right?
Yes.
That's what I'm doing. I'm multiplying it with the standard deviation and adding the mean.
Okay, sir.
Hello.
You were saying something. What's up, p-value? Okay. आपका क्वेश्चन है p वैल्यू क्या है इन अ टू टेल टेस्ट. तीन हाइपोथेसिस टेस्टिंग में p वैल्यू अलग अलग से कैलकुलेट होती है. इफ यू आर डूइंग अ राइट टेल टेस्ट, राइट टेल टेस्ट अगर आप करते हो, p वैल्यू इज एरिया टू द राइट ऑफ द टेस्ट स्टैटिस्टिक. इफ यू आर डूइंग अ लेफ्ट टेल टेस्ट, p value is the area to the left of the t statistic, right? In a two-tailed test, p value is calculated as area to the right as well as left of that value. So what happens is, suppose you have got a test statistic of, so this is normal, right? Suppose you have got a test statistic of say 2, right? For example, right? Let's say you have got a test statistic value of 2. In a two-tailed test, what you will do is you will calculate area to the right of 2 and you will calculate area to the left of -2. Add them up, you will get the p-value. पर हमने यहाँ पे p-value कैलकुलेट नहीं किया है क्योंकि जरूरत नहीं पड़ा.
Sir, I have one question.
हमने यहाँ पे p वैल्यू कैलकुलेट नहीं किया, जरूरत इसलिए नहीं पड़ा क्योंकि हमने ये जो टेस्ट है उसको किया है एक्सेप्टेंस रीजन यूज करके.
Hello, what is the acceptance region?
One second, one question at a time. 0.025 is half of 5%. हाँ 5% is the significance level, है ना? तो अगर 5% is your significance level, then what is your acceptance level? 95%, correct? So if your acceptance level is 95%, when will you accept? You will accept if the test statistic will lie within a range such that the area within the range is 95%, है ना? ये समझ में आ गया? तो हमने ये रेंज कैलकुलेट किया है which encapsulates 95% of the probability. अगर आपका जो वैल्यू है वो इस रीजन से बाहर आ गया तो मतलब वो क्रिटिकल रीजन में चला गया जहां पे रिजेक्ट होगा। तो ये जो टेस्ट है इसको हम दो तरीके से कर सकते हैं। एक, आपका जो टेस्ट स्टैटिस्टिक है उसके राइट साइड का प्रोबेबिलिटी कैलकुलेट करो और लेफ्ट साइड का प्रोबेबिलिटी कैलकुलेट करो, वैसे भी कर सकते हो। दूसरा, जैसे हमने किया, ये वाला जो मेथड है इसमें पी वैल्यू की जरूरत नहीं है, इसमें हम बस रेंज कैलकुलेट कर लेते हैं। रेंज से अगर बाहर चला गया तो रिजेक्ट कर देंगे, अंदर आ गया तो एक्सेप्ट करेंगे। ये इजियर टू अंडरस्टैंड है, रिजेक्ट करेंगे। एट अ टाइम एक ही टेस्ट हो सकता है। ना, खैर उसको टेस्ट करने के लिए दूसरा इंस्ट्रूमेंट है, इससे नहीं होगा। यस, नाउ एनीथिंग एल्स?
Yes, sir, I have a question. Like in alternate hypothesis, we have three options. Either it can be less than, either it can be greater than, or not equal to. So in whether we check any of the conditions one at a time, will this value remain same where we say if p value is greater than 5%?
Yeah, this will remain same.
Okay.
Significance level will always be 5%.
Or a greater than value, it will always remain same, that p value is greater than 5%, reject alternate.
Exactly. Okay. We'll stop here, right? Now, what I want you guys to do is, please try to go over this over the weekend, because otherwise next 4-5 classes will be very difficult. Okay. Because I mean, you will not understand this in a single class, right? That's okay, that's fair. But please ask questions if you don't understand. I'll try to explain as much as possible.
Hello.